Okay, so this is a little test for us. Now that we have our three options for showing that two triangles are similar, you can either use angle, 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 side, or side, side, side. Those are the only three options that we have right now for showing that two triangles are similar. So let's go ahead and test that out, see how good we are. So let's look at our first pair of triangles right here. All right, what options do we have? Could we use angle, angle at all? Hopefully you said no, because notice we don't have the measure of any of the angles. We don't have any congruent markings. So if these two triangles are going to be similar, it has to be using proportional sides. It has to use side, 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 because we don't have any angles to go from. So what I do now is set up my fractions to see if I have equal fractions here. Okay, so line up your corresponding sides. The longest side of this triangle, which is actually down here, 12 is the longest side of this triangle, should match up with the longest side of this triangle. So 12 to 6. The next longest side on this triangle was 10. It should match with the next longest side on this triangle, 5. So 10 over 5. And finally, we have our shortest side of this triangle should match up with the shortest side of this triangle, 8 to 4. Reduce each of those. 12 divided by 6 is 2. 10 divided by 5 is 2. And 8 divided by 4 is 2. Notice they all equal the same thing. So yes, these triangles are similar. And they are similar by side, side, side. Okay, let's take a look at our next one. Here's our next pair. Do any of our little postulates over here work for these two? First of all, what could we use? When you look, notice I don't have the measure of any of the sides. None of them are labeled with a measure. Therefore, I cannot use side, 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 and I can't use side, angle, side. I just don't have that information. So if these are going to be similar, it has to be by angle, angle. And angle, angle is when we have two pair of congruent angles. Well, notice here I have a 32-degree angle and a 32-degree angle. That's one pair. And I have a 97 and a 97. That's a second pair. So yes, these are similar by angle, angle. All right, let's head on over to this example here. So again, notice none of my angles are labeled. None of them have a measure. None of them have congruent markings. So I know I'm not going to be able to use a postulate that has angle in its name. So my only option is side, side, side. Match up the sides. Again, start with, here's the longest side of this triangle was length 8. Match it up with the longest side of your other triangle, 4. Okay, move on. Here's the next longest side is 6. Goes with the, oh, whoops, sorry. I matched up the first pair wrong. That would be 8 to 6 was the longest side of that first triangle. Then my second longest side over here was 6. My second longest side here was 4. I apologize. And finally, we have our shortest side, 4, with our shortest side, 2. Okay, now we are going to reduce each of these. 2 goes into 8 4 times. 2 goes into 6 3 times. Okay, so that reduces to 4/3. 2 goes into 6 3 times. 2 goes into 4 2 times. That reduces to 3/2. And finally over here, we reduce to 2 over 1. Okay, none of these are the same, right? So these are not similar triangles. The only option we had that would work would be side, side, side. And when we put our sides into fractions, none of them were the same.